Great. So, as Kevin mentioned, my name is Jamie Favors. I'm in our heliophysics division at NASA headquarters. I'll share a little bit about this, actually just spend the next minute or 10 minutes or so talking about giant explosions in space. So I hope you are entertained. With that, just a couple ideas of what I hope you can take away from the next 10 minutes of this conversation. That even within heliophysics and space weather, though obviously geology is a huge part of what we will do with exploration, there are other science disciplines that are very interested and very applicable here. Heliophysics, space weather is one of those. Space weather hazards really become much more significant as we move beyond LEO. We'll talk a little bit about that and how we think about that and what we're doing about that. Space weather is really the focus of these initial gateway payloads, though other gateway payload opportunities will come in the future for other disciplines as well. Exploration, very similar to planetary science. It really is enabled by exploration, but what we do enables exploration to happen safely. And now I'll leave you with thoughts around Mars. And really this big idea that we've been pondering and working on is, what does an Earth-independent space weather capability really look like? So with that, I'll jump over the boring headquarters charts for the most part. Heliophysics division, I realize, is probably new to most folks in the room, understanding the fundamental physics that drives our sun and the interactions throughout the solar system and beyond. Space weather is really the application space within heliophysics. So thinking about that as that connection there. Our fleet chart, or as Nikki Fox used to always say, our baby chart, our family chart within heliophysics. What she would also say becomes applicable here for exploration. Anywhere you go in the solar system or beyond is interesting to heliophysics. Whether it's the surface of the moon, deep space, beyond Mars, anywhere you go, we can take meaningful, important measurements. And then our space weather program, again, I'll skip all the boring bureaucratic part and just point you to goal 5. It is very explicit that we do lots of exploration work within space weather, within heliophysics, both from a human perspective and a robotic exploration perspective. Okay, so space weather and human exploration. As I hinted at on that second chart, we've spent the last few decades just in low Earth orbit doing great science, but that magnetosphere has really protected us from the worst harms that are really become applicable as we move beyond that. As we get to the moon and Mars, these things have become more dramatic, also much more dynamic. What we need to be thinking about is, what are the monitoring that we have in place to be able to do those alerts, as well as the forecasting capability to be understand what's happening at the moon, what's happening at Mars and beyond. So the first of these, and I'll point out a few things here. So our first science payloads actually will claim to be number 1 because our payload integration document is 001. So we'll say Hermes is the first science payload going on Gateway. Just to kind of orient you here, so this is the first launch of Gateway, or CMV, the co-manifested vehicles, PPE in the back, halo up front. And to point you in the sun-facing direction there, you can see the solar panels top and bottom. And then to point out where Hermes is there on the bottom. Actually, we're on the starboard side, so just actually on the other side of the vehicle from this perspective here. What's interesting is there's 3 different science payloads going on this first Gateway launch, 2 external, 1 internal, all of them really focused on the full energy spectrum that's really relevant to space weather, even getting into those high energy things that are very, very important for the crew safety. So actually those very separate payloads do very complementary science altogether. Okay, so then the next topic, actually here at Goddard, not too far away, we within the heliophysics program have a space weather, Moon to Mars space weather analysis office. This analysis office collaborates with SRAG, the Space Radiation Analysis Group at Johnson, that's responsible for crew safety, as well as our NOAA partners. Very similar to the National Weather Service, there's a Space Weather Prediction Center that does very complementary type of activities. So these 3 groups work together to do this real-time analysis going on. NOAA doing a lot of the forecasting work, very focused on human exploration, though this Space Weather Analysis Office does a lot of work with robotic exploration as well. Quick example here for Artemis 1 is preparatory for future missions with crew. There was a real-time case study that went on for the full 25.5 days of this mission. The 3 groups working together multiple times a day, doing these forecasts, doing the analysis real time. Fortunately and unfortunately, there actually happened to be the 25 days that the sun wasn't that active in the last 12 months. So good and bad, right? But it did give us an opportunity to get together to plan and be ready for those real missions with real crew on board, where this become even more important. And there you see a large photo just a few weeks after the mission. All three teams got together to do a hot wash to understand what worked well and what do we need to improve going forward. Then Moon to Mars strategy, as we start to transition a little bit into Mars. Here, as you've seen probably throughout that strategy and architecture documents, our goal for heliophysics for objectives here, Hermes, I talked about just a moment ago, really focus on objective 1, objective 4, thinking about space weather. There's lots of really important stuff that we can do about the history of the sun as we get down to the surface in both of these places. Understanding the fundamental plasma and the dust plasma interactions on the surface is another really tantalizing thing from a science perspective and application perspective. And then the magnetotail in both situations for Moon and Mars. Okay, and then to leave on the Mars idea. So I'll set it up with that first bullet to tell you what is the concern when we think about space weather. From a good perspective, all of our assets in space that focus on space weather are very concerned with the Earth. We live on the Earth, that is a good thing for us. However, when you get to Mars, those assets become less and less relevant depending on where you are in the orbit, to the point where potentially crew at Mars would have no warning of a potential harmful event coming their way. So that's our concern statement there. That Moon to Mars Space Weather Analysis Office I was just talking about, working with the MAVEN team from Planetary Science, have started to actually develop what are those tools that we could have at Mars? What are the data products that we could have in place now to get ready for those kind of things? We've actually started to expand the heliophysics fleet. We've moved over the RAD instrument, or that high energy particle instrument that's on the Curiosity rover, has transitioned ownership over to the heliophysics division to start getting the space weather community more involved in using those data and getting up, new products there, as well as the ESCAPADE mission. And that's what you see on the left side of the screen. There's a future mission coming up from heliophysics, looking at energy transfer in the upper atmosphere of Mars. Sure. And then our next heliophysics decadal should be out in roughly about 12 months from now. Very similar to Planetary Science, we anticipate, that we don't know yet, there likely will be a lot of exploration focus within there. We've submitted a lot of materials to them and they've had a lot of questions. So there may be recommendations coming out of that decadal for another part of NASA science to be focused on exploration work. And then the final, kind of what I hinted at on that second chart again, is this thought about what does it look like to have Earth independent space weather capability? Maybe it is something like Hermes, that you would on the crew vehicle be making those science measurements that are useful for forecasting, but maybe it's whole new assets like ESCAPADE that are already at Mars being able to do this, that type of work. With that email address, I really want to make sure the heliophysics community starts to show up to your meeting more often. So hopefully this is the first of many conversations we can have going forward. So if you have thoughts about how to help us get our community here, please send me an email. Thank you.